So, my name is Mehad Bin Naveed, roll number 18B-035-Cs. My project is about hash table. So, why it is good to use these data types? So, let's consider the situation where we would like to store a Gmail ID and user's info. So, we had the keys as Gmail ID and values as user info. We like to store key value pair in an efficient manner, so the aim would be to insert or retrieve user according to their email addresses. We have keys to email address and the user, for example, username, age of user as the values. In conclusion, arrays are just like that. If we know the index, the insert retrieve operation can be done in of one time. Let's suppose the situation that we have an empty array with 7 slots of index from 0 to 6. We would like to insert user 1 to index 2. Of course, we can do it without any problem because array supports random access, which means we are able to access a given index in an array in a constant time. And then insert user 2 at index 5. So what if we want to get the user at index 2? We can get them in a constant time complexity. So we considered a balanced binary search tree and we came to the conclusion that we achieve log of n for several options including search. And the question is, can we do better? Yes, maybe we reach often constant time complexity. This is why hash table complexity came to be. If we use array as underlying data structure and if we know the index, then the insertion and retrieval operations are very fast. So we want to search for a given item with a given key. The key can be our email address. We see that in example. So we have the key value pairs, we have the keys, and we would like to get the slot in a set of buckets, basically the index of the array. We have the Gmail IDs and we have buckets or arrays of array slots. We have size of array which is equal to m. That's why the index starts with 0 and ends on m-1. So in general, we have n items to be stored plus m buckets in which we can store the items. The problem is keys are not always non-negative integers. We have to do pre-hashing in order to map string keys to indexes of an array. So, for example, how are we able to map Mehad Naveed? This is a string first name and the last name. How are we going to transform this name to array bucket? That's how hash tables are come to be. So, in key space, these keys are the email addresses denoted as K1, K2 and K3 that are keys. So there is a relationship between the keys and the array slots. So we map key to the array indexes by hashing, which is h of x. So how can we map a certain key to a slot in our array? Hash function is needed. Yes. We can map a certain key of any type to a random array index in hashing. So how can we map a certain key to a slot in our array? Well, hash function is needed. So hashing, we can map a certain key of any type to a random array index. So if we have integer keys, we just have to use the modulo operator to transform the number into a range which is 0 to m-1. So if the keys are strings, we can have the ASCII values of the character and make some transformation in order to end up with an index to the array. Hash function, that's what the hash function does. Distribute the keys uniformly into buckets. So we have n number of keys and m buckets, which is the size of the array. A hash function relies heavily on modulo operator. The h of x is equals to n modulo m. By the way, we should use prime numbers both for the size of the array and in our hash function to make sure the distribution of the generated index will be uniform. For string keys, we could calculate the ASCII value for each character, add them up and we can use the modulo operator in order to transform this value between the range 0 to m minus 1. Because for example, if we have an array with 6 slots and we generate an index, for example, of 10,000, of course we will end it up with the array index out of bounds exception. So we have to use this modulo operator in order to make sure that they generated in this case will be within the range we are considering. So what is collision? Collision is when we map two keys to the same bucket. If the hash function is perfect, which is an ideal case, then there are no collisions. It's very hard to construct a perfect hash function, so basically a collision occurs when key 2 and key 3 are mapped to the same array index, the array index 2 in the picture. There are two methods to resolve the collision. First is chaining and second is open addressing. So first we discussed about chaining method. In chaining method, we store both values at the same bucket, so we use linked list to connect them. For example, we have key 1 to be mapped to the index. What about key 2? It is going to be mapped to m minus 2. So what about key 3? It's going to be mapped to the same index. So we solve it with the use of a linked list. The value in m minus 2 index is going to store the value, of course storing index and the reference pointing to the next value, because we have to store two values of the collision. This is called chaining method. So another method is open addressing. We generate a new index for the item. For example, key 1 is going to be mapped to the array index 0 and key 2 is going to be mapped on m minus 3. The key 3 is going to be mapped on same index, so the array index m minus 3, which just means that there is a collision. We would like to store two values in the same array index. So in open addressing, we generate a new index for the item because we have come to the conclusion that this array slot is not empty. We consider the next array slot available, which is m minus 2 index. Collisions. So just summarize the collision. We see two problems to solve the collision in previous slides, which is of two ways, chaining and open addressing methods. Collision resolution with chaining was we put multiple entries into the same slot with the help of a linked list. If there are many collisions, then O of 1 complexity gets worse. Why? Because worst case scenario, when we map, we generate the same index for all of the keys. It means we are going to end up with a linked list because we have to store all the items with the same array index, so there will be basically a linked list. For example, if you want to find an items in a linked list, it's going to take O of 1 and not O of 1. That's why chaining method is not always a good solution, and it has an additional memory cost due to the reference. So for open addressing, we have three methods like linear probing, quadratic probing, and rehashing. In linear probing, if a collision occurs, we try the next slot. If there is a collision too, we keep trying the next slot until we find an empty slot. In quadratic probing, we try slots like 1, 2, 4, 8 units far away. And in rehashing, we hash the result again in order to find an empty slot. So we end up with an array index that's not empty. Then we are going to use the hash function again.